All right, so here's the second question in the week 3 math counts handout, and it says, starting at his house, Lee bikes 3 miles west, and then 2 miles north, and then another 3 miles west, 8 miles south, 2 miles west, and then finally in a straight line back to his house. So the question's asking, how many miles did Lee bike in total? And since this is a little bit hard to visualize or hard to calculate just based on a visualization in your head, let's draw this out. It'll make our lives much easier. So we're going to draw Lee. Lee is this little dot right here. Look, or we can give Lee a body. That is a very disproportionate body. Lee is back to being a dot. Okay, so Lee is going to bike 3 miles west. So here, 3 miles. And then 2 miles north. And this is not drawn to scale, guys. Or to the correct angles, but pretend it is. And then another 3 miles west. And then 8 miles south. Oh my goodness. 8 miles south. And then another 2 miles west. And then finally, in a straight line, back to his house. So, straight line, please. Okay, good enough. Straight enough. Okay, how many miles did Lee bike in total? Well, for all of these straight parts, it's pretty easy to see how many miles he biked, right? When he's turning, he goes west, and then north, and then west, and then south. That's just 3. Let me do it in a different color. We have 3 plus 2 plus another 3 plus 8 is this section. And then plus 2 when he goes west again. But then we have to go from here to there, and that one, it doesn't tell us how many miles that is. So how do we figure this out? Well, let's just think about the information that they did give us. They gave us Lee's entire horizontal motion and his entire vertical motion. So if we know that, well, we can think of it as, oh my goodness, this right here, this can be looked at like a right triangle. So if we figure out this vertical length and this horizontal length, we can use the Pythagorean theorem to compute the hypotenuse. So, what is this length right here? Well, this entire thing right here, that's 8, but we know that this section is 2. So this section, since these two added up is going to make 8, well, this must be 8 minus 2, which is 6. And so for this horizontal section, well, it's just this line plus this line. So this right here is going to equal 3 plus 3, which is also 6. So our triangle right here, it's going to have side lengths. The vertical side is going to be 6, and the horizontal side is going to be 2 plus 6, which is 8. And so we could do Pythagorean theorem on this, or we could say, let's scale this triangle down because smaller numbers makes it easier, and then we can just scale it back up. So we can scale this down by a factor of 2, which will give us, wow, it'll give us 3 and 4 as our side lengths. And you can do Pythagorean theorem to figure out the hypotenuse. We have a squared plus b squared, the 2 legs squared, equals the hypotenuse squared. So we have 3 squared plus 4 squared equals c squared. This becomes 9 plus 16, which is 25, equals c squared. So c, the hypotenuse, is equal to 5. But these 3 numbers right there, you should memorize that. That's called a Pythagorean triple. So anytime you see a right triangle with legs of 3 and 4, you know the hypotenuse is going to be a 5. Anytime you see a triangle with a hypotenuse of 5 and a leg of 4, you know the other leg is going to be 3. It just comes up a lot, and they're integer legs, all of them. So it's worth memorizing. But this isn't our actual distance because, remember, we scaled this triangle down by a factor of 2. So we have to scale it back up by a factor of 2 to get that the actual hypotenuse of this triangle is 10. So this final length that Lee travels at the very end of his journey, this distance, that is going to be 10. So when we add up all of these distances together, 3 plus 2 plus 3 plus 8 plus 2 plus 10, well, we have 10 plus another 10 plus 3, 2, 3, that's 8. So 10 plus 10 plus 8 is going to equal 28. And so this right there is the total distance that Lee has traveled.